In this example, it's a little more complicated because now I have both a series and a parallel. So first I'm going to look at these. These two are in series. So I'm going to find their total resistance separately. So the resistance of this section is really easy, right? Because they are in series, I can just add them together. So 150 plus 200, and I'm going to show my answer. Now I am showing my work. A lot of people say, well, I can do that in my head. But remember, part of our job as a physicist is to show our logic, show where we got our answer from, what we were thinking in order to get that answer. So 350 for that blue section. That blue section is in parallel with the 200 ohm resistors. So to find my actual total resistance, the complete total resistance of the entire circuit, I now have to go 1 over that 200 ohm resistor plus 1 over my 350. This is where we should be pulling at our calculators. Remember, whoop, this should be 1 over, I apologize. So I now can find out what my total resistance is. Now I'm going to do it in 2 steps. Remember, you don't have to write down the first step. I'm just writing it down so those that are using their calculator following along can make sure they're doing it right. So I'm going to do 1 divided by 200 plus 1 divided by 300, and that will give me my number. So I ended up with, and then the 3's repeated all the way along. So I have this number, it's in my calculator. I now want to find the answer, and I don't want to have to type this back in. What I'm going to do is I am going to just hit my inverse button. Remember, your inverse button looks like this or like this, depending on your calculator. Hit that button, it will flip it over for you. What it basically does is flip both sides, because this side I can flip in my head. So it's RT divided by 1, which will be the total resistance. And this side was flipped by my calculator, and I got 120 ohms. Sig fig wise, I get to keep that 120 because I had 3 sig figs in all 3 of my original numbers. And when I look at this, I know it makes sense because it's less than all the numbers I started with, right? It's less than 150, it's less than 200. And that's what's important, because we have to remember that the resistance reduces in parallel, and that's because of the reduction of crowding. When the electrons have more than one path, they split. That reduces the crowding, makes it less resistance to those electrons passing through, and that's what we get. Time for a therefore sentence.